Okay, so there are two applications of percentages in section 2.1 after we have covered the basics, all right? And one has to do with this concept of relative change, and the other is relative difference. Both of these have to do with comparing two numbers, okay? So change, of course, means from one number to another with respect to time, and the difference is simply to compare two numbers at the same time. All right, so let's look at the idea of relative change first, okay? Suppose that the number of coronavirus patients increased from 34 say at a school to 37 at the same school. What percent increase is this? Okay, so an important concept here is to differentiate between what is called absolute change and relative change. So absolute change, by this fancy term, all we mean is the numerical difference. Okay, so what is the numerical difference? Difference is the word we use to denote the answer to subtraction, right? So basically, all we are saying is find the difference. 37 minus 34. So this is the new number. This is the old number. And of course, we are comparing the new with respect to the old, right? And so the new number is 3 more than the old number. And that is, this number is called the absolute change. Okay, and it's positive because the number is increasing. The relative change, the word relative has to do with a percentage. Relative to what? Relative to the number that used to be the previous number. Okay, so in order to calculate the relative change or the percentage change, we take that difference, the absolute difference, which is 3, and divide it by 34. So we are trying to figure out what 3 is, what percent 3 is relative to the base number of 34, which was the old number. Okay, so when you do this division, 3 divided by 34, you get 0.0882. Make sure you use a calculator again, which turns out to be about, remember I use this method of moving the decimal point 2 places to the right. And so this is 8.82%. So you can say that the number of coronavirus patients increased from 34 to 37, which represents 8.8% increase. Okay, so but the key here is to always use, maybe I should use a different color here. Okay, so the base, always use the first number or the beginning number, in this case 34, okay, as the base. And so that's something that you really need to remember when you try to find the relative change when numbers change. Okay. All right. Now let's go to relative difference, which is the percentage difference. Okay. Now this is even a little trickier because in this case, you don't have the old and the new. You're just comparing two numbers. Okay. So let's say my neighbor has a very fancy car that is $50,000, whereas my car is $40,000. What is the conclusion? Well, I must be jealous of my neighbor's car because his car is better than mine. That's not the point, okay? A, how much more is my neighbor's car compared to mine? Okay, now the emphasis here is compared to mine. You see how implicitly this part states what the base number should be, okay? And how much less is my car compared to my neighbor's car? Now the comparison base is different. All right, so let's look at A first. Oh, by the way, before I do this, let me just go ahead and write the absolute difference. Okay, just like the absolute change, the absolute difference is just a numerical difference between these two numbers. So usually you want this number to be positive. It doesn't have to be. See, in the case of an absolute change, you go from the old to the new number. So the direction is very clear, right? So you say positive 3 means increase. If this number were negative, that means it's decreased. Well, in this case, you just look at the higher number minus the lower number. In this case, the $10,000 difference is the absolute difference. Okay, now let's look at A. How much more is my neighbor's car compared to mine? So here, what we do is you divide that $10,000 difference, the absolute difference, by the base, which is compared to my car, right? So the base here is going to be the price of my car, which is 40,000. And that's of course 1/4. 1 divided by 4 is 0.25, which is 25%. So you can say my neighbor's car, let's say my neighbor is a man. And so his car is 25% more. Maybe I should say his car costs 25% more than mine. Okay, and that would be the correct statement. Now, if you're answering the part B, how much less is my car compared to my neighbor's car? Then what you do is, remember now, my neighbor's car is the reference. So I have to divide the absolute difference by 50,000, which will give you 1/5, which is 0.2. Here, let me just go ahead and be consistent, right? 0.2, which is 20%. All right, so I can say my car costs 20% less than his. So this is tricky, right? Because the percentage is different. Why is this 25% here for part A, but 20% for part B? Well, because the base is different. And that's because the reference number, the reference for the comparison is different. The first reference for part A was my neighbor's car, the price of my neighbor's car. And for the second part, the reference number is the price of my car. Okay, compared to my name, for the first one, the reference is my car, and the second one, the reference is my neighbor's car. Okay, so let's go to the last part of this, identify the base number correctly. This is one of the most important things that you have to watch out for in sections 2.1 and 2.2. Anytime you talk about percentage, if you are given the percentage number, always ask percentage of what, right? And it comes to be extremely important, especially in the second section. All right, first, if an item is 25% off, okay, let's say you have a sale, all right, and something is being sold at 20% discount. Then what you have to think about is that you are actually paying for 75% of the regular price, or you're paying 75% of that regular price. The way you look at this is maybe here is the entire object, okay, 100%. And 25%, of course, is 1/4, right? And so what you see, this part is discounted, which means you are paying the rest of the regular price, which is 75%, because the total is 100%, right? And this comes in, and this is very important for you to remember, right? Now, why am I saying this? Well, let's look at number 2. Suppose a pair of nice shoes is on sale at 20% off. And the sale price, you can buy this at $100. Now, what is the regular price? Here's what most people do. Most people will just add 20% to $100 and you get 120. So you say, well, the original price must have been $120. The answer is that is not the right way to do this. Okay, let's see why. Well, okay, maybe you can tell why this is wrong. Okay, if the original price were $120, 20% off would be $24 off of this, which will be less than $100. Okay, so that's why, I mean, that contradiction shows that $120 clearly cannot be the original price. And the problem is that when they say 20% off, this percentage, 20% is not 20% of $100. It's a 20% of the original price, right? And so the way you think about this is $100, this is how much you would have to pay to buy this on sale, is because it's 20% off of the regular price, it's 80% of the original price. All right, the reference number is the original price, which we don't know. What we do know, however, is that $100 is 80%, that's 100 minus 20, 80% of the original price. So the question becomes this, 80% of what number is 100? Okay, so the reference number is being asked. And remember, whenever you have to ask for or find the reference number, you have to divide the part by the percentage. So 100 divided by 0.8 is the correct operation you have to perform. And the answer is 125. Just get your calculator out and put 100 divided by 0.8 and you get 125. So this is the original or regular price. All right, and it makes sense. You may want to check your answers every time, whenever you do your question, you answer a question, you want to check your answer. If 125 is the original price, what's 20% of that? Okay, 20% of 125 happens to be $25. So you knock off $25 from 125 and you indeed get $100 for your sale price. So your answer is right. Okay, and then finally, if a population or anything increases by 10%, know that the new population is 1 plus 0.1. That's 110% of the original population. Make sense? If this was your 100% and you add 10% to it, okay, then altogether, the whole thing is 110% of the original population or the original quantity. Try to apply that to the last question. Suppose the enrollment at some college has increased by 15% to the new number of 41,400 this academic year. All right. So we don't know what the enrollment was last year, but we do know that the enrollment has increased to 41,400 over the period of 1 year. And this happens to be a 15% increase, right? So what you have to think about is this is 115% of the previous year's enrollment. That is what you have to think. You cannot calculate 15% of 41,400. That would be meaningless in this context. What you have to realize here is once you add 50, see, just like over here, you added 10% to the original population. So the new population is 110% of the original population. Just like that. In this case, what you are saying is 115% of last year's number is 41,400. So the question is 115% of what number is 41,400? So again, you're looking for the base number of what, right? And so you have to divide the current number, 41,400, divided by 1.15, which is 115%. Remember, whenever you look for the base number, you do division. And this will turn out to be 36,000 precisely, all right? So that is the number of people that were enrolled at this college last year. Now, again, you can do your own checking. If you find 15% of this number here, that would be 5,200. And if you add 5,400. And if you add 5,400 to this number, you get 41,400. So you know that answer is correct. Okay, so these are the basics and some of the applications of a percentage. Do your quiz, and next time in section 2.2, we'll see trickier and maybe a sort of a misleading use of percentages. Okay, but that's all based on what you learned in section 2.1. So be sure you understand everything about section 2.1 before you go on to section 2.2. All right, that's it for this section. Have a wonderful day.